Hello, folks. Welcome to IEE 475, Simulating Stochastic Systems. I will be your instructor, Ted Pavlic, and I just wanted to give you a quick introduction to the course before we get started this semester. Although I try to re-record these introductions every semester as information changes, you should always check the syllabus online for updated information. It's posted on Canvas. If anything does happen throughout the semester, I'll make sure to change it there. And so that really is the gateway to the most updated info about this course. In general, Canvas is a great place to look for information about this course. I've tried to organize our Canvas webpage to be just jam-packed with information that I think might be useful to you. So the main places that you should look when you go to Canvas are primarily the modules page. You'll find course information about your final project, which we'll talk about a little bit here, units and labs and exam prep stuff. All that has already been loaded in there under modules. There are additional ways to find that information under Canvas. If you go under assignments, there are ways in which you can sort things by date, or you can sort things by type. So that's an alternative way to find those assignments. But generally, most assignments have already been placed inside the modules as well. Of course, you can also find your grades. There's a feature called What If Grades, which you've never used in Canvas. I encourage you to try. I have a page in the course information page that talks about how to use What If Grades. But basically, if you have a grade that is upcoming, that has not been graded, you can go in and ask Canvas, what would my final grade be in the situation where I got a particular grade on this upcoming assignment. So it allows you to sort of see what's possible. So if you're not quite sure, maybe you're on a bubble between a certain grade and another grade, and you want to see, is it possible for you to go over that bubble, and what score would you need on an upcoming test in order to do that? You can use a what if grade to do that. So that's just something to look out for there. And of course, the syllabus, again, is posted on Canvas, and that is really the main course policy. That's kind of the more binding contract, is that syllabus that's on that on Canvas. And so I'm going to try to give you the most updated info here, but again, go back to that syllabus on Canvas to make sure policies, definitely the up-to-date policy. Okay, so when you go into Canvas, the last thing I want to mention about that is when you click on modules, it might be a little bit overbearing at first. And so you go onto modules and you're going to see a lot of info. The first thing you might want to do is jam that collapse all button on the upper right-hand side of the modules. That will collapse all these modules here, so you can just scroll through these module sections to find the information that you need. And those are organized on Canvas in my course, so that the top couple of modules are all about course information. So where you find general information about the course, where you find the classroom recordings, we'll talk about that, in semesters in which we record the lectures, and you'd find them there. There's a software program called Arena that we will use. So where can you find information about how to install Arena, how to use Arena, those sorts of things, and so on. So all that is up top here. The next section of modules are all of the lectures, so lab lectures and our normal classroom lectures, that are grouped by type. So lectures, lab lectures, as well as all of the kind of assignment groups are grouped together here. So I mentioned you could go to assignments and group things by assignments. I've also sort of done it for you here. So those are the first kind of sections of Canvas's modules. And that really is almost all of the information that you need from the course, all broken up that way. Now, some people would rather have that information broken up kind of in chronological order as we move through the units of the course. And so that's what the rest of the modules are. So if you scroll down to the bottom of the modules page, then you find I've got these Unit A, Unit B, Unit C, all the way up through the final units here. And in each one of these units, if you open them up, they've got all of the lectures and the labs and the assignments, all kind of interspersed together in roughly the temporal order that will go in as we go through the class. So some people like it in one way, some people like the other way. I've tried to provide it in both ways. Just scroll through. If you don't like it one way, just scroll by that and get the way that you do like it there. So that's the way modules are organized. Again, I highly recommend you smash that collapse all button in the upper right-hand corner, or else it might be a little bit overbearing to see all that information all at once. All right, so that's how you find information about the course. Let me give you a brief overview of how this course is lined up. Again, the most up-to-date info is in the syllabus. but here's a basic outline here that should hopefully be relevant in the semester that you're watching this. So the way this is organized, this course, is we have 2 lectures every week, 2 75-minute lectures, Tuesdays and Thursdays, and then one 2.5-hour laboratory. So that's the reason why this, at least in fall 2021, this is a 4 credit hour course. So it's the 3 credit hour laboratory plus the 3 credit hour lecture plus the 1 credit hour laboratory. It's the idea here. I will be the main instructor of record. There is going to be a lab TA and possibly a grader helping me out with this, depending on the semester that you're in and how many people have signed up for the course. When you need to email any of us, me, the lab TA, or the grader, then you should always include IEE 475 somewhere in your subject. This will help me find your message quickly among all the other mail that we get. It's really helpful so I can triage things and prioritize things if that's possible. If you give me a little description in your subject of what your email is about. So here's some examples here. So if you had a question about homework B1, you would say in your subject, IE 475, question about homework B1. So then I could see that, and I would know, depending on where I am, whether that's something that I need to read immediately, or if I can wait until I get back to my office, for example, to read, so I can help to get back to you in the appropriate time. Lab-related emails that you email should be addressed to either the lab TA directly or both me and the lab TA. If you just email me about a lab-related issue, let's say a lab assignment that you'd like to be checked because you thought maybe you got a couple of points off that you didn't think you should have taken off, I will have to consult the lab TA anyway. And so you should just put the lab TA in the loop to begin with. So either email the lab TA directly or email us both. But if you email me, then I'll have to get the lab TA linked in anyway. And it'll be much faster for you to get this resolved if you just email the lab TA initially. Okay. So what is simulating stochastic systems? So the main objective here is to help you identify, model, and analyze stochastic systems using a computer simulation framework. So that is kind of a bad definition because we don't necessarily know what all those words mean just yet, but those terms will become clearer soon, probably by the end of next week, Unit A. Breaking that out a little bit more, drilling down more into that, basically, we are going to teach you how to use this tool called simulation to build these models that you can incorporate into decision-making processes. These simulations are going to be built using modern computer-based software that help you combine data from the real world with mathematical and probabilistic models that allow you to test, say, changes in operations that are hypothetically better for a particular system. And so it's going to allow us to build models of systems of relevance to operations research that are linked to data from the real world that allow you to run tests on those computer simulation models before you can run tests in the real world models. That's basically a rough idea of what we do in this simulation. And that's basically, it goes into this other bullet, third bullet down here too. To do that, we're going to have to also use a lot of not only probability to build these models, but statistical inference. So we're going to learn a lot of statistical techniques to help us work with those data and compare those data with the data that we're going to get out of these simulation models. And so I mentioned data. There's going to be a lot of data-driven, what we're going to call verification, validation, and calibration of these things. These are, again, all terms that we're going to define as we move down through here. So in a nutshell, you're going to learn how to use computer simulation and real-world data to build models of the real world that help us improve operations and be able to build compelling and convincing arguments based on those models that incorporate statistical reasoning. Okay. So the learning outcomes that you're hopefully will have coming out of this course is that you're going to be able to hopefully identify the systems that are really best fit for this process that I just outlined there. You'll be able to build, once you've identified those systems, build a simulation model of those systems, be able to determine what we refer to as these input data requirements. So you're going to be able to find out what sort of data that you need to gather to parameterize these systems and how to parameterize these systems so that your simulated model produces outputs that are very similar to the real world. And then statistical methodologies to help you interpret data and make statements about the performance of your simulation model and how it reflects performance in the real world. And then communicate all of this via written reports to an audience, which might not have a strong simulation background. So simulation is going to call upon mathematical frameworks that you're familiar with, but it is going to hopefully provide you tools to communicate with people who maybe don't have those frameworks, but will actually find your simulation outputs to be very compelling because of how realistic they look. So we'll get all into that as we go down into Unit A. So related to that Unit A here, so the basic flow of this course is the next unit we're going to go into, Unit A, is what I'm going to actually drill down into what we mean by simulation modeling. And that's going to be an overview of simulation in general, the different types of simulation. This course focuses on one particular type of simulation, discrete event system simulation, and that's why Unit B is going to be focusing on that type of simulation. We are then going to motivate why we use discrete event system simulation over some of the other simulation methodologies, but you are going to get some exposure to those other simulation methodologies. In particular, you're going to at least have one lab on agent-based modeling. And so that will be something you can contrast with discrete event system simulation. Agent-based modeling is another type of stochastic simulation. So we'll be able to sort of draw comparisons there. So then after going through all of that, where we're going to be, pretty firmly introduced to simulation, then we're going to start getting into the math of it all. So in Unit D, we're going to then review probabilistic modeling that you've probably seen before in 380 and 385, and maybe extend some of that. So remind you about these fundamentals of probability and how they relate to building simulation models. And the connection between probability and computers are so-called random number generators. And so we'll have Unit E on what is a random number generator, how do you build a random number generator, and how do you use a random number generator to build a computer simulation model. After all of those fundamentals, we're going to have a midterm, and the date for this midterm you can find on Canvas, and that'll be over all of those units. Now, we do something in this class called a two-stage exam. Now, in a two-stage exam, what this means is there's going to be, the exam is actually stretched over 2 days. It's the same exam stretched over 2 days. The first day is a totally individual exam. So that you're going to be on your own. You're going to be allowed 2 sheets, 2 formula sheets, 2 pages, 2-sided formula sheets that you could use on that exam. Otherwise, it's closed book, closed notes, not allowed to collaborate with anyone. You do it yourself in a 75-minute period, and then it's done. And that's individual, and that will be 80% of your midterm score. A solution set will not be released for that one, but you're going to give a couple of days just to think about that exam. And then later, so let's say you take stage 1 on Thursday, the next week, say on Tuesday or the next Thursday, then we'll have the stage 2 exam. So in the stage 2 exam, you take that exact same exam again. But at that point, you can collaborate with anyone in the current class period. You can use your notes, you can use your book, you can use resources on Canvas. You can't use any other resources. You can't use anyone else, but you as a class together can share your work, and you can work with each other to try to better your scores from the previous one. So, so that is a way in which you can hopefully learn from each other after you've all experienced the exam alone through stage 1. And then that score that you get on that sort of almost like a retake exam, but it's like a group retake exam, will then become 20% of your midterm score. And that's how we do the midterm, and that's also how we're going to do the final exam. All right, so after that midterm, Then we start going into the more applied portion of the class. So the first portion of the class are like the fundamentals of simulation and probabilistic modeling. The second half of the course are sort of the more applied and statistical features. So we're going to start getting into things like, all right, now that we know how to build simulation models, how do we customize those simulation models so that they match data from the real world and generate interesting outputs that help us make inferences about the real world. And so we'll start talking about things like input modeling, which we'll start to define even next week, as early as Unit A. But input modeling basically is a way of taking data from the real world and turning them into probabilistic distributions that can be implemented inside your simulation models. Once you've built that model, you need to verify that your model is working, and then you need to validate that the outputs of your model actually look like outputs you'd see in a real world system. That's verification and validation, V&V, which we'll cover in Unit H. Then finally, we're going to be getting into looking at the outputs of our models and then drawing conclusions about the real world system. So we make changes in our computer simulation. How do we then draw conclusions about what would happen if we made those changes in the real world? And that's going to require some additional statistics. And so we're going to do a statistics review and then do that performance estimation that I was talking about there in Unit J. And then after all of that, then we'll have all of the tools to do useful stuff with simulation, but our simulations may not be as optimized. And so we're going to close things with what's so-called variance reduction techniques, which are ways in which we can make computer simulation models faster so that they become a more practical tool to use. So everything before VRTs is just how do we get simulations up and running? And the simulations we get up and running might take a little long to run on our computer simulation. Then in Unit K, we use clever statistical techniques to actually make our computer models run faster. And then that kind of closes things out. So then we'll have our final exam at the very end. That'll be cumulative. It'll go over all of this stuff, including both the lecture and the lab material. And that again will be a two-stage exam. Now, this final exam is going to be crammed into a 75-minute period because stage one of the final exam will be during the last week of classes. So whereas a lot of final exams that only have one stage that take place during finals week fill up the larger final period, then the two-stage final exam will end up being designed for just a 75-minute period. So it will be a shorter final exam, so that we can make sure that you can do stage one during that period. All right. Okay. Now, that's the basic high-level view of the topics of the course. There's, as I mentioned, this course has got a lecture component and a laboratory component. The laboratory component is meant to complement the lecture material to give you an opportunity to practice some of the tools that you will learn during the lecture. And so these are the practice experiences that we've put together to complement that. Again, mainly just fundamentals about simulation to start with. And then we kick off, starting in Lab 5, an introduction to the main simulation program that we'll use in this course, a program called Arena by Rockwell Automation. And so basically Lab 5 through Lab 10 are going to be all based on Arena, how to build simulation models with Arena and how to use Arena-based tools to deal with data from the real world and then get them back into Arena. So that's what's going on there. And then we'll have some lab periods that are left open, and they're meant to be there to provide you extra time to work with your group on the final project, as well as to get help from the TA and from me on this final project. All right. So what do you need coming into this class? Well, what I'm counting on is that by now you have some background in some type of programming, like something from CSC 200 or CSC 205. We're not going to be programming in a language like C, C++, or Java. We'll be programming primarily in this language called Arena, which is a very different language. It's kind of a graphical programming language, but there's going to be an emphasis on logic flow, on looping, on sort of like, well, if you understand how a program, you might say, well, I don't remember all of my C++ or all of my Java, but I do know how to flow chart out the basic flow of a program. That's what I need you to know going into these Arena programming assignments. And then from probability and statistics, we're going to do a lot of probability and statistics in this course. So leaning on classes like IEE 385, emphasis on probabilistic modeling, probability distributions, as well as inferential statistics, particularly hypothesis testing. T-tests, for example, we're going to see a lot of t-tests. We're going to talk about ANOVAs. We're going to talk about goodness of fit tests like chi-squared tests. These are all things you're going to see and hopefully become more comfortable with using in this class. Now, what other resources are available? Well, for the lecture side of things, there's this nice book by Jerry Banks et al. This is a book which does not cover ARENA. The simulation platforms you see in this book are going to be like Microsoft Excel and things like that. And that'll actually be a useful contrast to ARENA. But it does cover the simulation fundamentals really well. So that's why we use that in the lecture. Over here, there's this Kelton et al. Book in the lab, and that is an okay book for simulation fundamentals, but it really covers ARENA very well, which is why we use it in the lab section here. So you just need to get access to these books. See Canvas for access options. It may be that you may not have to buy fresh new copies of these. I have some alternatives available for you on Canvas on where to find access to these books and get access to them. So definitely check out Canvas for details there. All right, so I mentioned that this Banks et al. Book is a book that's going to be linked to the lecture material. If you go down inside any of the units or any of the lecture module inside modules on Canvas, you'll see that next to every lecture, there is an identification of a chapter. The idea here is that you're supposed to read that chapter in the textbook before coming into that particular lecture. So the idea is you see how Banks et al. Put that material together, and then you come to lecture with that basic idea from Banks et al. In your mind, and then you're going to be able to then hear the way my take on that and be able to interact with me using information that you have read through the textbook. And so make sure that you read whatever these chapters are before the lectures that go along with that. And there are some due dates that have been peppered throughout the Canvas calendar that'll help remind you when this chapter content is due, when those lectures are coming up. All right. Other materials that I recommend that you get, like I said, ARENA. You can download ARENA from Rockwell Automation. As a little bit of a warning, in late 2020, they made an update to ARENA from version 16.0 to 16.1. And it is a major UI, user interface update to ARENA. ARENA looks very different in 16.1 than it did in 16.0. So much so that it may, when you look through the ARENA textbook that we have, then a lot of the modules are not going to be in quite the same places. Now, it's not that hard to find them, but at first, it's going to look like a totally different program. So I've put information online about how to make this conversion. Unfortunately, we don't have an update to the textbook for the 16.1 version. I could have made you all download older versions of ARENA and use them instead, but there's probably going to be somebody who will download the fresh version from Rockwell. And the downside of that is if you create a model in the fresh version of Rockwell, you can't open it in any of the older versions. And so we're going to put all the newest versions and all the lab computers and so on. We're just going to have to push forward now with the newest version of ARENA. And unfortunately, the documentation we have and some of the old screenshots we have are of the old ARENA, but all of the same stuff is there. It's just in a slightly different place. And again, I will put notes wherever I can about where to find the 16.1 stuff where to find the pre-16.1 material in 16.1. I'll try to remind you of that during lectures and during labs and on the Canvas site, just as a warning about that. Now, if you have a Windows machine, you can install ARENA yourself. It's a free download, as mentioned here. If you don't want to do that, or you don't have access to a Windows machine yourself, then there's this SIDC virtual lab that works out pretty well, where you can actually log into the SIDC virtual lab from remote, and you can run ARENA on a machine that is actually hosted at ASU. And you may need to access that through the ASU VPN. So there's information about that at these pages here and then online on Canvas as well. Other things that I'll mention is there is every semester there is a student international competition that has some nice monetary prizes. I'll mention more about that periodically, but if you're interested in that, take a look. The submissions to the Student International competition can also work towards your final project. So you might want to take a look at that. If you need more help with Arena, there's also a lot of other resources online. I also recommend that you have access to a spreadsheet program like Microsoft Excel or Google Sheets. We will do a little bit of spreadsheet work as we start introducing simulation basics. You may also benefit from other platforms like MATLAB, Mathematica, R, Python, stats packages. If you want to make use of these, especially the stats packages as we move through here, that's fine. I'm not going to be covering them directly. I might give you some MATLAB tips periodically, but otherwise, these are things that I'm not going to explicitly cover, but they definitely, all the stuff that we talk about in this class are going to be relevant to these things. And so it's not a bad idea to make use of these to find connections between our material and these programs. And a lot of these programs are available to you as students from myasu.edu under the My Apps. All right, other materials, there's NetLogo will be a tool that we will introduce. It's available for Mac, Windows, and Linux. It's a free downloaded. It's a great agent-based modeling introduction tool. Other things like AnyLogic is a tool that is used in some of our other classes like IEE 477, another nice simulation tool that would be great to compare. It can do all the things that Arena can do. It just does them in a slightly different way. And a bunch of other packages here you might want to take a look at, which you'll get some exposure to in one of the upcoming labs, at least some awareness of as we talk about other simulation programs. All right, so the basic course structure here of how the activities are arranged. There are these so they're lectures, and there will be these lecture attendance that go along with these. And I say collect at the end of potentially every class. In semesters where we facilitate asynchronous attendance to the class, then I actually leave the lecture attendance surveys open for 24 hours after I post the lecture video. So if you're in a semester where we enable asynchronous participation, then you don't have to come to class. You can watch the lecture videos asynchronously, and then you can submit your attendance exercises, not during the class period, but up to 24 hours after I post the lecture video. Otherwise, if you attend class, you are certainly welcome to submit them at the, they're peppered kind of throughout the class period where you actually hit submit at the end of the class. And so we'll see more details about that as we move forward. There's also these online kind of these activities that have a healthy drop policy, which you can see in the syllabus for the particular details here. Same with the lecture attendance. There is a super healthy drop policy for the lecture attendance as well. So again, see the syllabus for these. So you can miss quite a few of these lecture attendance and interactive Canvas activities. So these Canvas activities are meant to help you work through the book reading material. And so they're going to be due before the associated lecture. So they're meant for you to, as you're reading through the chapter, you're going to sit there with a Canvas activity, and it's going to ask you questions to help guide your reading through the chapter and what you should be focusing on. Then we've got homework assignments. There's only a couple of these, and so there's not going to be any drop policy, but there's only, I think, 5 of these, and so there's no drop policy on the homework assignments, but I'll give you a late submission policy of 20% per day if you happen to turn it in late. Like I said, there's a midterm exam, a final exam, there are 2-stage exams, and then there's this final project, which I'll give you more details about in the next slide, and then these lab assignments. And there's a healthy drop policy on these lab assignments. Again, see the syllabus for the details on that. All right, the final project, this is a group project. So it is traditional in simulation courses for there to be a term project where you do a simulation on a real world system. That's what we're going to do here. And so this project, which is primarily going to happen after the midterm, you're going to form a group of 3 to 4 people that depending on the semester and how many people are in the class, there may be some tighter constraints on whether it can be 3 or 4, so we'll address that in your particular class, but you're going to form that group. you're going to then come up with sort of a proposal and some data, a proposal on what system you want to model and some data on that system that helps show that you're moving in that right direction. And then after that input modeling report, you're going to build a simulation model, and you are going to use that simulation model to demonstrate, say, potential performance improvements that could happen if someone to make changes in that system. And then you will create a video presentation of your results that you'll upload to Canvas during the middle of the last week of classes. So this is like during the day of the normal lab during the last week of classes. So I emphasize this is the middle of the last week of classes is when you upload that video presentation. And you also upload a specially formatted 4-page project report, again, during the middle of the last week of classes. So during that Wednesday, the middle of the last week of classes. And the idea is that you're going to upload those things to Canvas. You're not actually presenting the whole class. You're just doing that video presentation uploaded to Canvas. And then once that's all up in Canvas, the reason you're doing it in the middle of the class period is that you're going to have the back half of the last week of classes for you to do a peer evaluation of another group's presentation and another group's report. So every individual person will have to do a peer evaluation of one presentation from another group and one report from another group, and you'll submit those. And so I will use the peer evaluation scores of the presentations and the reports when I form the final scores for the presentations and the reports. And so the grade for your presentation that you submit and your report that you submit will be in part taken from the grade that your peers give you. And so, so you'll actually be able to participate in the evaluations there. All right, then, some other things, just, I kind of alluded to this already, but homework assignments, they're gonna have these funny names, homework B1, and the lectures will also have a similar sort of naming here. A homework is named for the lecture that it's assigned during. And so homework B1 means a homework that you are ready to do after lecture B1 concludes. And so you can think of lecture B1 as being the official day that that homework is released. Now, I am going to try to release these homeworks well ahead of time so you can work on them ahead of time, but they will officially be released during the lecture that they're named for. Now, on the flip side of it, the Canvas activities, which are these online Canvas exercises, are named for the lecture in which they're due. So ICA A2 says this is the Canvas activity you should do before lecture A2. So that's how those two things are named. All right. Okay, so I mentioned late policies, homework, 20% per day late, but no drop policy. Lab reports may not be turned in late, but there's a healthy drop policy. Check out the syllabus for details. The final project may not be turned in late. Oh, and this is a mistake. This shouldn't actually say drop policy. So I'll make sure that I get rid of that in the archival version of this. So there's no drop policy there for the lab reports. Remember, there is a drop policy for the attendance, for the lecture attendance. See syllabus on policy for excused absences. Basically, you got to let me know in advance. That includes religious observances. You got to let me know those in advance, preferably at the start of the semester, because you know those things are going to happen. So you let me know in advance, and then I can make an excused absence for those. If there's a medical reason that you have to miss a particular date, then you need to let me know after that as soon as possible. So as soon as you're well enough to get me a doctor's note or let me know that that you missed that, then we'll deal with it however we need to deal with it. But don't come back, be healthy for the rest of the semester, and then at the final end of the semester say, oh, by the way, I missed that homework because I was at the doctor's office and I was sick for a week and I couldn't turn it in, or something like that. As soon as you're well, let me know that you were out because of for a medical reason. And then generally, when things verifiable documentation of those sorts of medical excuses. All right, grade correction policy. If you receive a grade back from the grader, from the lab TA, from me, you got 1 week that after you get that returned to review it and then notice any issues with the scoring. If there are any issues with scoring, you got 1 week to come back and say, oh, I noticed a problem with scoring. Can we get this fixed? So if, again, this is one of those things where I don't want to deluge people at the very last week of classes saying, oh, the homework that I turned in the second week of class had these points that were off. You know, if you don't notice it after the first week, then I can't help you. So look after the first week after you get those assignments returned. That's the time to do the grade corrections. And then I have to mention this, but in ASU's academic integrity policy on the provost webpage, it says specifically that it is a reportable violation of ASU's academic code of conduct if you were to request a grade change for any reason that's not related to how well you've done on that particular assignment. And so you can't request a grade change, say, to maintain your scholarship eligibility or to graduate on a particular schedule or to maintain visa status or any of that. If you come to me and say, oh, I got a B- on this assignment, if I just would get a B on this assignment, then I can maintain my scholarship eligibility. I am bound by ASU's code of conduct to report that as an academic integrity violation, because that's tantamount to cheating, for example. And so I am obligated to report students who make such requests. So don't request that from me. It's fine to come to me and say, I got a B- on this assignment. I think this answer that was marked wrong was actually right, and here's the reasons why. That is an excellent thing to come to me with. But don't come to me and say, I received a B- on this assignment. Is there anything you can do to turn it into a B so I can make it maintain my scholarship eligibility? There's nothing I can do in that case. You got to get the B- in that case. And now that you've asked, I've got to report you. Okay. Other things that, copyrighted course material and commercial note-taking, material that I distributed to you are copyrighted to me. They may not be redistributed. That means you can't upload them, you can't sell them, you can't transfer them in digital or analog form without my permission, and I don't give you that permission. You take your own notes, and those technically are copyright to you. But if you upload your own notes without clearing it with me, that's a violation of ASU's academic integrity policy. So don't sell your notes. Don't post assignments or assignment solutions onto online forums. These are clear violations. They're reportable, and there's not a lot I can do. I have to report those things when they come up. Unapproved collaboration is another thing. I encourage you to work with your peers to help achieve a greater understanding of the material. I get that, and I encourage that. But if an assignment is an individual assignment, as nearly all assignments are in this class, and they're all individual assignments unless they explicitly say otherwise, then that means that you cannot just work together on the same assignment and submit the same answers. Your submitted answers must reflect your understanding. So this means you can't copy. If I ask you for examples of a particular simulation concept, you cannot use the same examples of your friend. Now, you and your friend might come together and you might brainstorm different examples, but you should submit your own set of examples, and your friend should submit their own set of examples so that your work is distinct. All right, so wrapping up here, there will be a number of in-class exercises that we will do during lectures that you can actually participate in asynchronously if this is during a semester in which we permit asynchronous participation in the course. So the first one is you're going to see slides that look like this one that'll have questions across it. And then they've got this QR code down here and this URL down here. If you visit that URL, Or if you use your phone or other mobile device to scan this QR code, it'll bring you to that URL. That will bring you to a page where you can anonymously submit questions related to the lecture material. Now, if I'm not too stressed running around like a chicken with its head cut off, then I will pay attention to those during the lecture. And you can see other questions that other people post and vote them up so that they go higher up in the list. And then I will then use those anonymous questions to hopefully try to answer during the lecture. But if I don't get them during the lecture, I will review those after the lecture, and I will post answers to those questions on the Canvas discussions and maybe in the Slack channel. So that's a way that you can anonymously post questions if you don't feel comfortable raising your hand, or if you're participating asynchronously, you can submit those questions. The other thing that you'll see are these attendance exercises. It's a similar idea. There's going to be this QR code over here. There's going to be this URL over here. And if you visit that QR code or that URL, then it will open up a Google form. Now you will have to log in with your ASU ID. You have to be careful about this to use your ASU ID, not your Google, your normal Gmail address. And so if you have a Gmail account or another Google account, in order to make this work, you may need to open up, say, an incognito window in your browser. So you only have to do this once. Or just some sort of a fresh tab or something like that. And in that incognito window, you may need to go to Google Drive or Google Docs and log in with your ASU account. And once you're logged in with your ASU account, then go to this URL. And when you go to this URL, then it should be logged in with your ASU account, and you should get access to it. And what you'll see there is a Google form that's got 10 blank fields where it just says like question 1 blank, question 2 blank. What you're going to do is, whenever you see one of these attendance exercises during a lecture, I will then ask you a question related to this attendance exercise. And that might be the first question of the day, the second question of the day, or whatever. You'll end up putting your answer to that question. Like I might ask you, what is 2 + 2? In which case you would go to question 1 and put in 4. And then you just leave it there. You do not hit submit at the bottom. We're going to go through the lecture more and more, and then another one of these will pop up. And then I'll say, okay, what is 5 × 5? And then you'll say 25, and you'll put that under question 2. So by the end of the lecture, we'll have gone through several questions, maybe 3 or 4, probably not 10, maybe only 1, but they're going to be spaced randomly throughout the lecture. Sometimes I'll have a slide in this in the slide deck, but I'll choose not to use it. The questions will generally be related to content that's in the lecture that happened before that slide. You're going to put your answers into there, and by the end of the class, when I say we're all done with attendance questions, you click submit. And when you click submit, then that will submit that to a form, and that form will allow me to take attendance for that day. And so what that allows me to do is I will scan through there and make sure the answers are coherent. They do not have to be correct, but they do have to make sense as answers for the questions that I asked. So if I said, what's 2 + 2, and I look at someone's answer and it says nothing, or it says, simulation or something like that, then it just shows me that that was like a random answer, and then you won't get credit for that, and you won't receive attendance points for that day. But as long as you have something that looks like it could be an answer, even if it's not the correct answer, you will get attendance credit for that day. So that's how these attendance exercises work. If you're attending class during a semester where we permit asynchronous participation in this class, then after I post the lecture videos, you'll have 24 hours where you'll be able to go and attend and complete these attendance exercises. And then after that 24-hour period is when I'll review those things and get everybody their attendance credit on Canvas. Okay. All right, so my closing reminder here is check the syllabus. That's where all the updated policies are. If there's been any changes to this, it'll be in the syllabus. Check the syllabus, check Canvas. Where to go next? Canvas. So at this point, I want you to go to Canvas, and sometime between now and when it's due, complete all of the Unit 0 activities. You will not be able to open up any of the other modules inside Canvas until you complete all of the Unit 0 activities with a perfect score. those Unit 0 activities, you'll be able to complete multiple times until you get that perfect score. Once you get a perfect score on all of the activities in Unit 0, then you'll be able to move on and unlock the rest of the course. Canvas will also tell you that Chapter 1 is going to be due soon. So start reading Chapter 1, which is an introduction to this stuff, Banks's introduction to this stuff. Look for the first ICA assignment, which I think is ICA A2. It will be due before the lecture that shares its name. So if it's ICA A2, it'll be due before lecture A2. So do that at home before that lecture. That's kind of like a homework assignment, and that will help guide you through any related reading material. So check that out. And then start looking into Lab 1. So Lab 1, I think will start, next week. And usually the way these labs work is if your lab is on Wednesday, the lab will be due on Sunday. And so you can start the labs ahead of time. I made all the labs available ahead of time. You can turn them in ahead of time. You don't have to wait for us, but the labs are timed so the lab material kind of fits in with the lecture material, but all the lab lectures are already out there. So you're already free to watch all the lab lectures and complete the labs ahead of time. And again, check the syllabus. There is a healthy drop policy on those labs. So you may not end up needing to complete all those labs anyway. Well, that's all I've got for you. If you've got any questions, feel free to reach out. And I'm looking forward to working with you this semester on simulating stochastic systems.